trying to understand what is this machine learning, right? How
So
does it?
like two essential things we are trying to understand. Okay, it is just the bunch of numbers is what we are trying to understand. Okay, what goes in as input is basically bunch of numbers. What comes out is also bunch of numbers. In a
Yeah.
kind of a deterministic model, the outcome is basically predictive and probabilistic. In the
Mhm.
case of a generative model, you are simply trying to generate a next token and then trying to showcase. In the case of a text, it is the next token. In the case of an image, that is basically it uses a model called diffusion model. Even image is basically converted into something called tokens, which is a 16 by 16 pixel token. So that is what it happens under the diffusion model. Okay, that's a different story, but that is also basically tokens. So essentially, what is be it generative AI, ML, or whatsoever it is. So it is basically bunch of numbers going in, bunch of numbers coming out. This is the essential fact which you should have learned by now. If you have learned that, then that is something that was the goal for all of our first half of the session. Is that
Mhm.
clear, or is still
Yeah.
something is unclear?
Yeah. Fairly okay.
Right? How does this happen? Is absolutely a different story, right? Like BP algorithm, transformer algorithm, neural networks. So the network, what I did try to show you here, is basically called your fully connected neural network model. Okay. So this kind of a network. Where is network? Where is network? This network is basically called your fully connected neural network. Okay. You can have more number of layers and then more number of nodes. Absolutely all right. Okay. You have any number of layers and then any number of nodes. All right. So this kind of a network is basically called your fully connected neural network. Again, there are so many varieties of neural networks. So you should have heard about like convolution neural network, recurrent neural network, and then LSTM kind of a neural network, reinforcement learning kind of a mechanisms. So there are many other kinds of networks. Okay, so the transformer itself is also another kind of a network. So you have variable encoder networks. All of these networks are basically a different kind of an orchestration of all of these nodes. Okay, now you can see how complex can this become, right? So yes, so that is about that. But essentially, as a whole, when you say learning, you are discovering your weights and bias. And then when you say like in a discriminative model, output is predictive and probabilistic. In a generative model, the output is basically creative or generative kind of a thing, right?
Mhm.
Any further questions, comments, feedback?
This 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 is looking like that. They show now when quantum computing, they show that all the pictures you have that
Mm,
connection of those wires and this one. Uh,
true, true,
these
true,
nodes are
true.
looking like that
But this
only.
is not at all quantum computing. If you think this is complex as much as quantum computing, then quantum computing is 100 times more complex than this.
No, zillion
Because
times
like
more.
when you say, yeah, I mean to say like this basically works with only logic 0 and logic 1. But the moment when you try to bring in quantum computing, you have a tri-state kind of a thing. So two of the states are logic 0 and logic 1. The other state is always like a tri-state. Okay, so that is much more complex. So now let's not really get into that. But yeah, to visualize, I simply try to show you this like very chota project. And when you see this network is with only 311, and now you simply sit and dream about what would be a neural network model which has got 1,000 neurons or like 1,000 weights, and then think about like what will be about 1 billion. If you think this is a mess, that will be a super mess. you know it's so like kind of a cop mess, like the so many nodes, so many are connected, so many are disconnected, and so many varieties of connections and all.
Just for our purpose, put as many large number as possible, which this can accept. What is the largest number it can accept?
I basically made this for students.
Yeah, 10
It can
there.
take 10, 10, 10, 10, 10. Everything has 10.
Okay, then
And this is with you. You should also give it a try and then look at it, you know.
Uh, show the picture how it is.
That is how it is.
So geometric pattern. Huh?
Like, okay, again, this is all fully connected layer, so it looks maybe like a rangoli. Okay, in real time, we do not use all fully connected layers because there is also a problem called what you say, um, out overfitting and underfitting kind of a situation. All right, so such could also happen, but yeah, that
This
is
is
how
how
big
many?
it is.
This is how many parameters it shows.
We'll go back there. That is 1031. So
Uh,
this is still much less than 1 million or 1 billion kind of a thing. 1 million is so like let's try to make a statement. 1 million is 1,000 times more complex than this, and 1 billion is thousands of thousand times. So 10 to the power of 6 times it is more complex, to put it like that. Right?
mhm.
All right. Okay. Again, so let's
Right,
try
right.
to not get into more technical side, but that is that. Okay. Okay. So if there are any questions, I'll take now, or else we'll part for lunch. Is that clear so far? So the next part, we'll try to make it more interesting. We'll stop discussing technical AI side of it. So a little bit of engineering side is what I did try to touch upon. So the next session, we'll try to touch upon the not really the engineering side. Rather, we'll try to more look from an user perspective side. Okay, so that will be more interesting. We'll try to look
Mhm,
at three different tools: Langflow, Google AI Studio, and then the Notebook LM also. Okay, we'll try to learn from them. Yes.
mhm, mhm. Oh,
Right.
good.
Ganapa, you still have some queries?
No, no, no. I mean, okay, it's good. I think. When we'll meet? 2 o'clock,
We'll come back by
2:30.
2 p.m. Is 2 p.m. okay for everyone? Please give me thumbs up. If you have another proposal also, you can ping me.